Hey everyone, today we'll be focusing on graphs today, particularly focusing on adding an edge between two vertices in a directed graph, and without any further hesitation, let's get started.
And now going over our direct graph. So, part two, what we will usually be doing is that we're going to be including our libraries, which should be the following. I'm going to have 3, 4, 5, 6 libraries to include as well. So I'm going to go include Iowa stream, include vectors, I'm going to include a stack, include a queue, I'm going to include a list, I'm going to include algorithm, and we're going to include our header file. And also, just a note, our GraphPrinter header file is applicable to 6 of the graphs that are already listed in here. Again, the descriptions already contain the GitHub link, so you can look at the README to see in particular on where the GraphPrinter actually applies in this case. So we know exactly where it's being printed, and the only different variations that we have are going to be inside of the on the weighted graph, and then we will have the undirected graph. Those are really the big 2 graphs that have those different modifications. But again, just for disclaimer and just letting everyone know. And then finally, what we'll be doing is that we will have using namespace std as well. And then what we will be doing is that we are going to have our class over here. I'm going to call this directed graph. And I'm going to have a public instance over here. We are going to initialize our variables by number of vertices by int v over here, and then we'll have an adjacency list of, you guessed it, a vector list int. I'm going to call this adjacent, and then we're going to have our constructor that we're going to call, which will be directed graph int v over v here. Then adjacency list resize, so that way we could be able to call upon it based on the vectors that we're actually putting inside of it as a parameter. Just be sure to put the semicolon. Yep. Okay. Then the next part, I'm going to be focusing on adding an edge. Then going over the question, remove a directed edge from vertex v to vertex w, since we are dealing with 2 vertices, because in order to have a graph you need 2 vertices along with an edge. And then we will move a directed vertex and all its associated edges. Then we are going to perform depth first search iteratively, starting from vertex v, and then perform DFS recursively. Then we will do the same thing for breadth first search as well. Search, breadth first search. And then all we're doing right now, since we're going to be focusing on the first part of adding an edge, what I will be doing, and this is going to be insanely easy, all we need to do is have this function, void add edge, that we call int v and then int w, since in order to have a graph you need 2 vertices along with an edge. And then all you have to do is that inside of our list of vectors that we're going to have, we're going to push back, add it in context with w. So this is how we connect 2 vertices with an edge accordingly. And now I'm going to be able to test this thing out to make sure that we have everything already set up in place, and also be able to print out the necessary graph as well. So we're going to have directed graph. We're going to call this graph with 6 vertices altogether. So you have 0, 1, 2, 3, 4, 5. And then graph dot add edge, based on the function that we have, we need 2, so I'm going to have 0, 1, and I'm going to put in the other ones, and this is how we are going to connect. 2, 3, 4, 5, 6. So that means we're going to need 1 and 2, 2 and 3, 3 and 4, 4 and 5, 5 and 0. We're going to return 0 at the same time. So let's just build this, make sure it's all good. Alright, and it's already set up in place. And also I'm going to call upon GraphPrinter, and I'm going to call this printer as well. And that means just with that, all we need to do is just print out printer print graph based on the following vector. So we have graph.adjacency list that we made from our vector. And I'll put the semicolon over here. So let me just build this. Build succeeded. We're going to run this. And it showcases our graph already. And we have the graph adjacency list, so that way we know exactly what is already connected. So based on, let me just zoom over here. So after we have added the following edges, this is what our graph is going to look like. We notice in our graph adjacency list we have 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 0. And the following graph we have for our directed graph, notice the arrows and the constant direction that we have. That's indicated that is a directed graph. And it's also in a circular fashion, which means it's cyclical, and a non-circular fashion means acyclical, just for further context as well. And so, yes, this was adding an edge for our directed graph. Now we will be focusing now on removing a directed edge and a vertex as well, based on the next two problems that we have. So we can do this either way, but again, I'm just putting the removes next to each other in particular. That's the next step that we will be doing.
Hey everyone, thank you very much for taking time to watch this. If you found this video helpful, be sure and feel free to please like and subscribe. And if you have any other questions or suggestions, please put them in the comment section. And as always, take care. Cheers. Bye-bye.